Hello, it's Mr. Van Ong here with Distance Learning Week 3, Day 4. And we are in My Math, Lesson 11 of Chapter 11, which is on page 865. Mr. Van Ong, we skipped a lesson. You skipped a lesson. I know. It's on purpose. Calm down. We're going to be talking about metric mass today. Not so much converting the metric mass, but measuring it. Similar to when we did the measurement of customary mass, we don't have scales, and the scales that we would have even at school are kind of garbage. So that's not the point today. The point is trying to understand generally kind of how big these masses are, what mass is, why I'm not saying the word weight, and then to be able to solve the problems and practice it before we begin the conversion process tomorrow. So mass is how much of something there actually is. It's different than weight. For example, Mr. Van Dong, on Earth, I have a certain amount of mass. I am this much mass. Okay? And if I stand on a scale, I have a certain amount of weight. Right? And weight is the measurement of gravity's pull on mass. So those are different things. How much of me there is and how much weight I have when I stand on a scale are different. They're different because if I were to go to the moon with the same scale and the same Mr. Van Dong, if I have the exact same mass, even wearing the same clothes and holding my breath on the moon or something like that, if I step on that scale, I'm going to suddenly weigh a lot less because the moon is so much smaller than Earth, it has less gravity. And so it's pulling down, it's pulling my mass down against the scale less hard. Whereas if I could somehow withstand the atmospheric pressure of Jupiter, the largest planet of our solar system, if I could somehow survive its winds and its atmosphere, which would tear me apart if I was there. But if somehow I could stand there, even with the same mass, Jupiter is so much larger that if I stood on a scale, I would be tremendously heavy all of a sudden, even though nothing about my mass has changed in any of those cases. Or if I was floating in space, I would weigh nothing. I would weigh nothing when I'm floating in space, but I would have the same mass. So again, the difference here, mass, how much of something there truly is. Weight, how much gravity is pulling down. So in metric mass, we use something called grams. And a gram is a very, very, very small measurement. And 1 gram is one, I believe, milliliter of water on Earth or something like that. Out of this, everything works out nicely, and I don't remember the details. You can look it up, and I'll give you imaginary extra credit. No, I won't. But no, you can imagine it. So the metric mass is, our base unit is grams. It's very tiny. And right now you're like, grams? Like graham crackers? No, not like that. Gram, GRM. Spelling is hard. So we're dealing with grams. And usually when we talk about how much something like a person weighs, we don't talk about it in grams because a gram is such a tiny amount. A gram is like, I think 2 pennies, I think is a gram or something like that. I think it's 2.5 grams is a penny. So a gram is very, very light. We talk about kilograms for how much like a person weighs. Like if we lived in Canada and wanted to go buy some pasta or some rice, we would not be buying a pound of pasta or a pound of rice. We'd be buying a kilogram of pasta or a kilogram of rice. So a certain amount like that. So, and then like I meant to say this yesterday and I didn't. The customary system and the metric system are not friends. They do not get along. They will not share space at all. It's not like, oh, a pound and a kilogram, those are going to be about the same. They're not. And I bet it's 2 kilograms. No, it's not. Like you can Google how many kilograms in a pound right now, and it's going to give you this long decimal. And that's how all of them are. They do not speak nicely to each other. They're always these ridiculous decimals. So it can kind of help for us to try to understand how big these things are, but it's not perfect. Okay, rant over. We use kilograms for bigger objects like a person. We use grams for smaller objects like the amount of ingredients you might put in something like a recipe, or how much yarn weighs, if you're going to figure out how much yarn you need to knit a sweater, or mailing something, how many grams it weighs, for you charged by its weight if you're going to mail it, so kind of smaller objects. And then we use milligrams, which are really small. A milligram is 1,000th of a gram. So take half a penny and cut it into 1,000 pieces. One of those pieces is a milligram. We measure medicine in milligrams. So you look at medicine in a medicine cabinet, prescriptions from doctors and things like that. It's a certain amount of milligrams. I wonder if I'm frozen for you too. My screen froze there for like 10 seconds. So if you saw me going like that for 10 seconds, then you saw me going like that for 10 seconds. So milligrams are a very, very, very small amount of mass that we use for measuring medicines and vitamin supplements and things like that. Tiny, itty bitty, small amounts. All right, let's take a look at their problems here, and we'll see what we can do without the scales. It says estimate the mass of each object in grams and then record your results. Go ahead and don't do that. Turn the page. A kilogram is a measurement of mass. A kilogram is equal to 1,000 grams. Use the table to complete the chart below. Yeah, let's do that. So if we've got grams and we've got kilograms, so we've got, ooh, that's beautiful writing. Kilograms and we've got grams, just like they've got right here. If you've got 1 kilogram, you've got 1,000 grams. If you've got 2 kilograms, that means you've got 2,000 grams. And so on. 3,000, 4,000, and so on. Again, like I told you, the metric system is so nice for these conversions. Everything is always a multiple of 10 in one way or another. Kilo literally just means 1,000, because there's 1,000 grams in 1 kilogram. So everything plays nice, which is good. So let's jump into the practice it section. Let's see what we're actually going to be able to do at home with this assignment, because it's obviously going to need to be modified without the scales. It would have been modified at school as well, so don't panic. Identify 3 objects in your home that you could use a balance to find the mass of. Okay, so if you're watching this right now, then you have access to the interwebs. And if you have access to the interwebs, you have access to Google. And with parent permission, then you may Google some of the following things I'm about to tell you. Maybe pick some objects, guess how many grams they would weigh. So if you're measuring in grams, don't pick big things. We're not going to try to estimate how many grams are in a car. Okay, pick smaller things, right? Pick a basketball. Pick a book. Pick a video game console. Pick a apple, a sandwich, something like that. Pick those objects. Guess how many grams they would weigh, and then Google it. Google how many grams are in an apple, and they'll say, most apples are about this many grams, and then kind of compare. Okay, so we're trying to get a sense of about how much mass do common objects have around us, and we can accomplish that with a little Googling. So you can write what you Google here, write your estimate, and then look up the exact amount of grams those things typically are. Doing big objects? No. Doing pretty small objects for grams. And then down here, even though this isn't technically about a conversion, like doing conversions, that's what you do here. So just like before you solve, let's do number 6 together. Before you solve, make a prediction. So number 6, we're comparing 1,500 grams to 1 kilogram. And I abbreviated them, and whatever. So once you get the hang of this, the prediction part kind of like doesn't make sense because it's so snappy and easy. That's a big number. I picked that one. That's my prediction. Okay, and then now I'm going to actually check. Now, 1 kilogram is, according to our previous chart that you should still have written down, 1 kilogram is 1,000 grams. So this is equal to 1,000 grams. So what's bigger, 1,500 grams or 1,000 grams? So it becomes pretty straightforward as you continue to progress through these. They do give you decimal points later on, like 3.5 kilograms. Well, 3 kilograms are 3,000 grams. What would half of a kilogram be? Half of 1,000. You can figure it out. All right, so finish these comparisons, fill out your chart right there. Tomorrow, we're going to really dive into conversion and fill out the back page as well. And see you tomorrow.